clock policy. The clock replacement policy is called the second chance replacement policy. In the clock page replacement policy, the candidate pages for removal are considered in a round-robin method, and the page that has been accessed between consecutive considerations will not be replaced. This is example of our clock policy. There are 3 slots of memories and 12 page address streams that we already chose, which are 3, 4, 3, 2, 6, 3, 5, 6, 4, 3, 6, and 3. For the first step, take a look at our current page. Our current page here is 3, so 3 will be added in first frame as the pointer pointing at first frame, and the bit will be 1. In here, the star refers to 1 bit. Then, the pointer will move to the second frame. Next, we need to add 4 in memory. So, as the pointer pointing at the second frame previously, and luckily, the frame is empty, we can add 4 in second frame and the bit will be 1. The pointer then will pointing at third frame. Let's move to the next stream. Here, we need to add 3 in memory. As we can see here, the memory already have 3, so it will remain same and the pointer also stick at the same place. Number 2 is the next page address stream that need to be added in memory. As the pointer previously remaining the same and still pointing at the third frame, so 2 will be added in third frame and the bit also will become 1. The pointer then will move to the first frame. Now we need to add 6 in a page frame. Unfortunately, 6 cannot be added as the pointer pointing to 3 and 3 already have bit 1. So we need to turn bit 1 in number 3 to become 0. Next, 4 also will be turned 0, same goes to 2. After that, we can look here, after we change all the bit became 0, the pointer pointing back at 3, and now we can replace 6 at page frame 3. So, this page will become page fault. F here means page fault. When we successfully added C, the bit will become 1. Next, we're going to put 3 in page frame. 3 will replace 4 as previous pointer pointing at the second frame. The bit in 4 is 0, and that means we can add 3. So, the bit for 3 will change to 1, and it became page fault. The pointer also will move to the third frame.
Page 5 pointing at the use bit of 0 at number 2, so it can be replaced here by 5 bit 1. The reference pointer will be at 0 and this page will be page fault. The next request page is 6, but 6 already have in the memory, so there will be no change in number and the reference point. Also, our next page is to put 4, and our pointer pointing at the 6, but 6 have already bit 1, so this 6 cannot be used and will be 0. The second frame, which is 3, also will be 0. 5 also have the bit 1, so we change it to the 0. And now finally, we can put 4 in a place of 6, and the reference pointer will set to the second frame, which is 1, and this page will be fault page. Page 3 have already in the memory, so we just add bit 1 to the number and it will be 3 bit 1. Plus, the reference pointer will be not changed. Next, it requests page 6. This is page fault. The pointer point at the number that has bit 1, which is 3, so we cannot use that number. Set it to 0 first and then move the reference pointer. After that, number 6 will move to the third frame and the pointer will set to the frame 0, which has number 4 bit 1. And lastly, it requests page 3. Page 3 are already inside the memory and the reference pointer will not move, but the reference page, which is 3, will be set to the bit 1 from bit 0. Here is our complete answer, and there is 5 replacement page of fall in the answer.